Hello everyone, today we will talk about the toxicity of lead. Lead, chemical element Pb, is an inorganic substance that is a dense metal. It is approximately 11.29 grams per centimeters cubed, and it is also a poor electrical conductor. It is highly durable and resistant to corrosion. It has the atomic number of 82 and the atomic weight of 207.19 grams. The melting point of lead is 327.5 degrees Celsius, and the boiling point is 1,744 degrees Celsius.
Since lead is easily worked and prevents corrosion, it has been known to be in paints, pipes, and pewters, as well as roofing and in stained glass windows for architecture. It is also used in store corrosive liquids. Today, it is widely used for car batteries, pigments, ammunition, cable sheathing, weights for lifting, weight belts for diving, lead crystal glass, and radiation protection.
Although lead used in these products are usually harmless, lead-based paint and lead-connected pipes cause very serious problems. Lead can be released into air, water, and even soil. This may be due to the natural presence of lead or other exposures from man-made sources. These sources include the flaking, chipping, or weathering of paint, improper renovation of buildings or the disposal of building materials, lead on roads that has settled out from burned leaded gasoline, settled dust from industrial sources, and lead around houses from lead paint that has been scraped off during the continual repainting of the houses.
Lead pollution impacts humans as it is the main source of lead poisoning. Lead from pipes may be released into water when the water is slightly acidic. In addition, lead may change forms when it comes into contact with sunlight, but it cannot be completely broken down. Particles of lead that are released into the air from weathering and aging of houses that use lead paint may travel and settle into the ground. It will bind strongly to soil particles and accumulate in plants and animals in that area. Humans are most affected by lead poisoning.
It leads to several medical complications that include permanent neurological damage in both children and adults. In humans, exposure to lead can lead to behavioral abnormalities, hearing deficits, impaired cognitive functions, and neuromuscular weakness. It can also lead to pathological changes in terms of toxicity in the kidney and the endocrine system. Additionally, high levels of lead exposure have been found to result in reproductive failure, reduced fertility in males, and miscarriage in pregnant women. Lead is toxic because of its ability to mimic calcium, which also leads to an increase in the spontaneous neurotransmitter release and a decrease in the stimulated neurotransmitter release. Lead poisoning contributes to the cardiovascular illness and hypertension as well. Long-time exposure to lead has caused anemia, increased blood pressure, mainly in old-age people, and severe damage to the brain and kidneys in both adults and children. However, children are more sensitive to the effects of lead because their organs are still developing.
The effects of lead are synergistic with other environmental contaminants. Lead and dimethylate have a synergistic effect in regards to relative body, liver, and thymus weight. Additionally, the synergistic effects of lead and mercury are very neurotoxic. Studies have shown that lead and arsenic have synergistic effects in regards to central monoaminogenic system. For humans, the lowest reported lethal dose is 450 milligrams per kilogram. For dogs, the lowest reported lethal dose is 300 milligrams per kilogram. For pigs, the lowest reported lethal dose is 500 milligrams per kilogram. For rats, the lowest reported lethal dose is 100 milligrams per kilogram. Sadly, lead poisoning will continue to cause a problem in the future, since lead was used in so many products before people realized the level of its toxicity. Nearly all homes built before the 1980s have lead connecting to the copper pipes. Even some major U.S. cities still use lead pipes to carry water from the utilities to our homes and businesses. This can put people in danger as children living in old homes can breathe in or ingest chipped paint or dust.
The United States is currently working to solve this problem by passing regulation like the Clean Water Act. The Clean Water Act prohibits anyone from discharging pollutants, such as lead, through a point source into a body of water in the United States, unless they have a National Pollutant Discharge Elimination System permit. The Toxic Substances Control Act regulates lead-based paint hazards, including paint, dust, and soil. The Safe Drinking Water Act regulates lead under the lead and copper rule. Lead in air is regulated under the Clean Air Act. Under the Clean Air Act, the EPA places regulations on how much lead can be in ambient air. The EPA also determined that lead-based paint can be disposed of as a household waste in an effort to reduce the amount of lead in and around homes.
In addition, we can reduce the amount of lead pollution by replacing lead products used in pipes with other metal substitutes. For example, to replace a lead tin solder used to attach electronic components to wiring boards, companies and scientists have started creating SAC solders made out of tin, silver, and copper. Other possible substitutes is to use ECA polymers. The most commonly considered possible substitute for lead include tin and germanium because they are also group 14 metals and have similar properties. Thanks for watching.